Good morning. Hope everybody's doing well. I'm going to try a little video here on drawing a forward and reversing motor schematic. All right, so what we have are two parts to this circuit. We have what we call is the power and the control. And in that power circuit, we're going to have line 1, line 2, line 3. This could be from any supply. I'm just going to pick 600 volt three-phase supply. Out of line 1, we'd come to a 3-pole breaker. And then after that, we'd come to the disconnect. And in the disconnect would be our switches, disconnect switch. Then we'd have a fuse. Both the breaker and the fuse provide overcurrent protection. After we leave the fuse, we're going to go out to what we call the horsepower rated contacts. And the horsepower rated contacts are related or will close when our coil in the control circuit is energized. And I'll get to that in a minute. After we leave the horsepower rated contacts, we have to get to our overload contacts, our overload heaters. It's important that we differentiate between that. I always draw those a little strange. And then over here, we have our motor. So we had our breakers in our main panel. This part here was inside our disconnect. And out here, we have our horsepower rated contacts. Which will close when the coil in our control circuit is energized. Next, we have our overload heaters. And they're also part of a relay that's called the overload relay. And so if the heaters have too much current flowing through them, they will actually open a set of contacts in the control circuit called the overload contacts. And then our motors. Okay, so now we need a control circuit. Often the control circuit is 120 volts. Because our supply is 600 volts up here, we actually have to bring some power down from here. We go through a little transformer. In the secondary of that transformer, then we would refuse, reground. I have a new little system. That's going to come out and feed our control circuit. So we're going to have 600 volts on this side and 120 volts on this side, because typically our coil down here would be 120 volts. Now I'm going to draw a forward reversing control setup for this motor. I just have a squirrel cage induction motor up here. Squirrel cage induction motor, very common motor, very practical motor, low maintenance, pretty good torque. So to start out with, we always put the stopping devices at the front of the circuit. So in this case, I'm going to put my overload contact at the beginning and then my stop button. And the stop button is a normally closed momentary button. When I move on from there, I'm going to go to a start button, which is a normally open momentary button. And this one is going to be for the forward direction of the motor. I leave there and go out. I want an electrical interlock. Now that needs to be normally closed. And that electrical interlock is going to be tied in with the reverse that I'm going to draw further down here. And we want that to be open if we're running in reverse. And then after that, I can go to the forward coil. And so we're going to label this set of contacts up here F. And so if this coil is energized, these forward contacts would all close and my motor would run in forward. And what I'd like to bring you to your attention is we're going to have line 1, line 2, and line 3 on this side, going off to T1, T2, T3 on this side. And you'll notice when I draw the next part that we have to flip any two lines in a three-phase motor to cause it to reverse. Now right now, I don't have a holding contact in my control circuit, and that means that if I push the button, my motor would run in forward, but when I release the button, my motor would stop. So I have to actually add a holding contact. This is often what we call the 2-3, the labeling on the actual contactor in your MCC. And this 2-3 is also related to this forward coil. So I could put a little F there just so that you can be reminded. So now when I push the start button for forward coil is energized. All of these contacts close. When this one closes, it is now providing power to the forward coil, even if I let my finger off the start button. This is called low voltage protection. So that if the power goes out, the coil would de-energize, this would open, my start button would be open, and then the equipment would not restart unless I came back and pushed the start button again. So that's sort of my rung in forward. And now what I want to do is add a rung in reverse. So I'll just go down here. I'm going to add another start button. This time it's going to be the reverse start button. I still need an electrical interlock. In this case, it's going to be tied to that forward coil. So if the forward coil is energized, this is open, meaning that even if I push the start button for reverse, it will not go and run in reverse. And then this is my reverse coil. Remember I mentioned that this reverse set of contacts protects us electrically so that we cannot run in forward if reverse is energized. So these two were opposing. So this is the reverse is up there and the forward is down there. And so if forward is, or if reverse is running, forward can't run. And then of course we need to return a path. Same challenge here. I have to add a holding contact. This holding contact now, actually not labeled 2-3. I can't quite remember the numbers on it. And when we come back to here, what we have to do is this holding contact now is related to the reverse. And so if I push the reverse button, my reverse coil is energized, opens the electrical interlock, so cannot try to run in forward, also closes the reverse holding contacts. And so then I can take my finger off the reverse start button and my motor will be running in reverse. If too much, I have to actually show you what happens up here. So we need a set of contacts related to reverse up here. And what I'll do is draw that in a different color. So I mentioned that all we have to do when we have this coil energized, we need 3 more contacts up here. And these contacts will be operated when I push the reverse start button and energize the reverse coil. So what we want is we still have line 1, 2, and 3 on this side. So this would go to line 1, this would go to line 2, and this would go to line 3 on that side. But what we want to do is reverse the order on this side. So often line 3 stays the same, line 3 to line 3. We're not changing the order of that. But up here where we had line 1 going to T1, we're now going to take that to T2. And I just made myself a little bit tight here. And now T2 will go to T1. So if we look at what happens now, if I push the reverse button, we energize the reverse set of contacts, which closes the holding contact, also closes our reverses, and now line 1 will go to T2, line 2 go to T1, line 3 still goes to T3. And I have to add one more thing, and that's a mechanical interlock. And that mechanical interlock then will prevent, so that's a mechanical cam right inside your contactor. And if you're running in forward, there's a physical entity that won't allow you to push, won't allow the reverse to be engaged. So basically we have two protections. We have the electrical interlock and the mechanical interlock. Both of those are designed so that we can't have forward running at the same time as reverse. And part of that, a big part of that, is if both of them were engaged, we'd have a dead short from line 1 back through here to line 2. Notice that this set of contacts, the forward set of contacts, is open if the reverse is closed, and vice versa. That's what that electrical and mechanical interlocking is all about. Prevent a dead short. Thank you very much. That was fun.